Welcome back to another installment. This time around, we would explore inequalities. Specifically, if you remember, when we did exponents, we did addition, subtraction, multiplication, and division. Similarly, as we explore this concept of inequalities, we would dedicate time to each of the four domains within inequalities, that is, adding inequalities, subtracting inequalities, multiplying and dividing inequalities. Okay, so this will be the very first video in the installment, and we will begin our discussion with inequality by addition, right? So let's look at the first problem. As you will see as we do these problems, that there are some things you have to do up front depending on the context that's provided, and that's what would dictate how you would solve the problem. Okay, you have to do some initial cleaning process right away as soon as you see the problem that it involves inequality, whether it's addition, subtraction, it doesn't matter. You have to do some cleaning work right away, and how quickly you can make that cleaning process, it's going to give you a way that you can use to solve the problem, right? So let's get started. Here we have what values of X make the following statement true, right? One good thing about inequality is you do not have to really focus on the answer choices for the most part as you solve the problem. So here's what I mean by. So here is the problem we have. So we have X minus 3 absolute is less than 9. What absolute means? The value inside could be entirely positive or it could be negative, which then becomes positive because of the absolute sign, right? Which means technically you have a positive or a negative outcome, okay, inside the absolute symbol, right? So here's what I want you to do. I'm sure there's probably another world of thought on this, but here's the way I have done it, and it never let me down. First, treat as if there's no exponent, okay? That's the first step. So X minus 3 is less than 9. Here's how you do it generally with inequalities is you want to make sure that you clean up everything around X, which means you're left with just pure X. Always plus X, okay? Or plus Y or plus Z. You might be wondering, what about the negative? Well, I'll definitely answer that. But here's the first thing you do. Whether there's exponent or not, you write it without that and then continue with the problem. So as I said, you want to get rid of everything that's around that X. That's what I meant by cleaning. The only way you can get rid of negative 3 is if you add plus 3 on both sides. That means what I'm saying here is add plus 3 on both sides, which makes X is less than 7. This is one extreme of X value, okay? We know X is less than 12, but is X greater than something? That's the second part. So this time, instead of, you're still going to not keep the absolute symbol, but last time we didn't use brackets. We didn't make any effort to indicate the sign. This time around, it's very important to determine the lowest end of the spectrum. Just take the X minus 3, this time around, put it within brackets and put a negative outside. Remember, we said plus or minus. We've already taken care of the plus. If you don't add any sign, that means it's plus. If you add a sign, then you are trying to emphasize it's negative. Again, retain the less than 9. So first time around, you don't do anything. Second time around, you just take the value, put it in bracket and add a negative. Let's multiply negative throughout. So it'll be negative. You can get rid of the negative by doing something simple. I mean, you could do one step. I'm just going to skip that step because I think it makes it easier. Instead of having the negative, what you could do is you could multiply negative throughout. What it does is it does two things. One, or you can, sorry, what I meant to say is you divide by negative, which is essentially, it's not going to matter whether you multiply or divide. So you're going to have a greater symbol and a negative 9. Okay, this is not a negative, by the way. I have divided or multiplied by negative, it doesn't matter. And then what it does is when you multiply or divide by a negative sign, you have to change the existing direction of the symbol. In this case, it was less, now it becomes greater. Because we're multiplying or dividing by negative throughout, we have to make sure that the negative carries over to the other side, so it becomes -9. Now you can keep the bracket or not, it's totally up to you. Now I want to get rid of everything that's around x. That means again, I still add +3 on both sides, right? Which means my x the -3 cancels out and x is greater than -6. That means we now know x is less than 12, x is greater than -6. So how do you write that? Write x in the middle. On one end, you have x is less than 12. On the other hand, x is greater than -6. And if you look at the answer choices, there is only one that exactly matches what we have, and hence that is the correct answer. Okay. This idea of cleaning that I've talked about and all the little things you have to do as you prepare to work the problem, that would probably stay the same for pretty much whether it's adding, subtracting, and so on. It's going to stay the same. You have to do that to make sure that you're getting it right. All right, let's look at the second problem. If -1 is less, W is greater than -1, but it's also less than 1, all of the following must also be greater than -1 and less than 1, except for which of the choices? Okay. There's two worlds of choice to this. You can assume a value for W and start plugging it into each of the answer choices and see where it does not follow the range. That is, the outcome cannot be greater than 1 or it cannot be less than -1. Okay, you have to make sure of that. Now, if you substitute W, I don't think any of the answer choices would be eliminated because absolute of 0 is 0, 0 raised to the power half is 0, 3 times 0 over 2 is 0, 0 over 2 is 0, 0 squared is 0. So W doesn't really help, right? Even though W is a likely component in that range, right? What if you choose something like, say, 0.99, okay? You have to choose, if W, which is 0, which is right in the middle, didn't help you, let's go to the other extreme where we just pick 0.99, okay? An absolute of 0.99, whether it's plus or minus, you can choose W -0.9 as well. Okay, it didn't matter. It's going to be 0.99, right? Or you can choose, for B, let's choose -0.99 over 0.5, which is same as square root of -0.99, which is same as writing square root of 0.99 because it's an absolute. So it's still going to give you very much a value that's less than 1. 3 times W over 2. 3 times 0.99 over 2 is greater than 1. Okay, right away. 0.99 over 2, well, that's same as W over 2. That will work, this will work, this will work. W squared is 0.99 squared is also will work. Whereas will provide a value less than 1. What will not work is this right here. Okay. You can also do it for 3 times -0.99 over 2. That will still be less than 1, which is also something we don't want. So 3W over 2 is the only correct answer. So when the question specifically states something about a choice, then please feel free to use the answer choice to work in favor of you. Now, again, this may not be time efficient depending on how you look at it, but the first time around I just applied 0, which is going to be easy, so you didn't really spend much time. then you just need to know the logic. If something in the middle doesn't work, always go to the extreme, either to the positive or negative extreme. And both gave me similar results because there's a lot of absolute in the equation, right? So either way, and this is an easier problem, but in some cases, the answer choices themselves might help you gear towards how you want to do the problem. All right, just like how we did problem 1, solve for a specific value of z. Now let's go ahead and first write it down. Irrespective of what the context is, to determine one end of the spectrum, because it's an absolute, you will have a positive or negative. So for the positive expression, you can just write z minus 3 greater than or equal to 5. And what do we have to do? We have to clean what's around z. And how do we do it? We have a negative 3. So if you add plus 3 on both sides, then we can clean out z. So the max end of it is z is greater than or equal to 8. Now to determine the negative component of it, write z minus 3, except this time put it in bracket and put a negative outside of it, and greater than or equal to 5. Right now, again, you don't have to multiply into the z or 3 or any of that, just multiply or divide by negative throughout, which would give you z minus 3. And when you do that, the sign changes and you also have a negative 5. Now, again, you still have to clean out negative 3. So you still had plus 3, which means it's negative 2. So the top end is 8, the bottom end is negative 2, which means z is greater than or equal to 8, z is less than or equal to negative 2. Is there an answer choice that fits it? Well, not specifically written this way. So if the answer choices themselves may appear individually or as a range like we did in number 1, in such a case, you have to write z is greater than or equal to 8, right? Z is great. Yeah, actually it's here. It's actually here. I didn't even see that. I thought it was for some reason. Okay. Now what is wrong with this? Okay. It's written wrong. That's all. Z is greater than or equal to 8. Here it's shown z is less than or equal to 8. So this fails. These all will fail right away. Z is greater than or equal to 8 is correct. But then z is less than or equal to negative 2 is also correct. So that's why this fails. So it's this. Because we don't even have a negative 3 or 5. I think how they got this is just simply they took the value straight out of the equation, and because those are distractors. That's the way people that design these tests think. They want to confuse you. They want to trick you. So essentially, they made it easier by just grabbing some values straight out of the question. So that's not true. All right, this will be the end of this video. I was trying to make short videos on these on this topic because there's just too many problems. Okay, I don't want to do 10, 15 problems at a stretch. So this will be the last problem on it. What value of x make the statement 5x minus 9 absolute greater than or equal to 6? Well, the logic doesn't change irrespective of how the question is written. So we have 5x minus 9 greater than or equal to 6. So for the positive component, we write 5x minus 9 greater than or equal to 6. We have to clean up the values around the x. So it's 5x. If you add plus 9 on both sides, it's 15. But again, we still have a 5. So we divide by 5 on both sides. So that means it's x is greater than or equal to 3. Now at this point, if you're really confident that you got most of it right, we know x is greater than or equal to 3. So this is incorrect, incorrect. Only these 3 are likely candidates for the answer choice. So let's go to the negative side of the problem. So we have negative 5x minus 9 greater than or equal to 6, 5x minus 9 less than or equal to negative 6, 5x is less than or equal to, what is it, plus 3, x is less than or equal to 3 over 5. Do you see what I did? I just want divided by 5 here. So x is less than or equal to 3 over 5, which makes this incorrect, and this is the correct answer. So if you have to write it in a domain range, you would write it as x is less than or equal to 3 over 5 is greater than or equal to 3. This is how you write it if you were to write it as a single term, right? If you haven't already done so, please consider subscribing to my channel. Your support would greatly help me do better in all my future videos. Please share the video with your family and friends, and I'll see you with another video on adding inequalities. So please stay tuned.